Start.
Hello everyone. Let me talk a bit about myself. I'm Mohammad Bilal Khan, doing my masters in mechanical engineering from University of Wollongong. The topic I worked on is to evaluate mechanical characteristics of Inconel 617 and stainless steel 316 by shear punch test. The contents covered today will be introduction, nomenclature of weld, types of welding process, research question, design, results, and the conclusion. First, let me back you all up with some basic information on welding. What is welding? Welding is an operation where two or more parts are united by means of heat or pressure or both. It is usually used on metals and thermoplastic, but can also be used on wood. Um Types of welding. There are two types of welding: similar welding and dissimilar welding. Similar welding. This is a process which involves joining together of two metals that possess same chemical or mechanical properties. Whereas dissimilar welding is a process involving joining of two metals that possess different chemical or mechanical properties, and so aren't necessarily a natural fit for each other. The reason the term can sometimes be slightly confusing because it doesn't only involves two completely different metals such as aluminium and steel. In fact, two metals with the same name can be welded together, but if they have different properties, it is classified as dissimilar metals. I have specified few nomenclature of weld so that you understand completely. Few terms, that is parent metals, filler metals, heat affected zone, and weld metals. So the parent metal to be joined or surfaced by welding, braze welding or brazing, and the filler metal is the metal added during welding, braze welding, brazing or surfacing. And the heat affected zone, it is a part of the parent metal metallurgically affected by the weld or thermal cutting heat but it is not melted. And lastly, it is the weld metal, the metal melted retained in the melt. That is the all the metal melted during the making of a weld are retained in the weld. There are many types of welding processes, but I have specified few of them because they act as a important process during welding. These are friction welding, resistant welding, and arc welding. What is friction welding, and how it can be performed? Friction welding technique joins material using mechanical friction. This can be performed in a variety of ways on different welding material, including steel, aluminium, or even wood. The mechanical friction generates heat which softens the material, which makes to create a bond as they cool. This is the schematic diagram of the friction welding. Resistant welding. This is a very fast process which is commonly used in the automobile industries, and this process can be split into two types, that is resistant spot welding and resistant seam welding. Resistant spot welding. It uses heat delivered between two electrodes which is applied to a small area as the workpiece are clamped together. Seam welding is similar to that of the spot welding, except it replaces the electrode with the rotating wheel to deliver a continuous leak-free weld. This is the schematic diagram of the resistant welding, in which a welding plate is used and electrode is placed on it to perform the spot welding. Arc welding. This category involves a number of common manual, semi-automatic, and automatic processes. This includes metal inert gas, tungsten inert gas, gas welding, gas metal arc welding, submerged arc welding, and plasma arc welding. These techniques usually use a filler material and are primarily used for joining metals, including stainless steel, aluminium, nickel, copper alloys, cobalt, and titanium. Arc welding processes are widely used across industries such as oil, gas, power, aerospace, automotive, and more. This is the schematic diagram of arc welding. Research question. So let's get to the research question. As I said earlier, my research question is to evaluate the mechanical characteristics of inconel 617 and stainless steel 316 weld by shear punch test. So let's get to the research design. The base metal I used are 316 stainless steel and the inconel 617 of specific thickness, size of 15 mm. And the filler material used to join these metals is inconel 617. The base metal is the welding process uses inert gas welding processes, and the welding parameters specified are welding speed of 3 millimeter, current of 100 amperes, and a voltage of 10 watts. Optical microscopes like Nikon is being used, and Leica is also used in terms of optical microscopes. The thermometer used is infrared thermometers, and there are mostly like 10 thermometers being used in this process. Shear punch test technique is being used to determine the mechanical properties, and Nikon image analyze software is being used to analyze the imaging that is recorded. And the equipment used for shear punch test equipment is Marksman MK75 SP. The test recorded is n number of times the test is recorded, and the average value is being taken into consideration. This is the schematic diagram of shear punch test. In this, the sample is being clamped by means of a clamping plate, and the stress is being applied in a vertical direction. So the results I got from conducting this research is that inconel 617 and stainless steel 316 consist of high strength, high ductility, and hardness. And the recorded ductility reduces as it moves away from the main welded region. Hence, I conclude that due to its high thermal expansion and mechanical properties, it is concluded that it can be used for high temperature applications. Thank you.